Welcome to MATLAB programming part 1. In part 1 we will do branches like if and switch statements. And so let's start. So an if statement, this means that it could be like just if and if else and if else if and if else and. So it could be like this is if you have one expression, this is if you have two expression like true, like one expression like true or false, and like here if you have a multiple expression. Let me just show you an example. So here is an if statement, like if the expression is true, then whatever here will be executed and then it will end. So for example, so I could have something like display high, for example, and then I want to make an if statement if the age is larger, age, like I have an age of 6. So I want to make a condition statement if the age is greater than or equal 3 and less than 5, then I want to display this message. So how to do this? So I say like if age greater than or equal 3, so greater than or equal 3, okay, and age less than 5, then is when you start like this statement, you must end it with end, like a for, like if you are like when you do like MATLAB programming, whether you're doing loop, whether you're doing branches, like an if statement, switch statement, for loop, while loop, you put like this end keyword. So and you put all your expression here, okay? And as it could be like 100 lines, wherever you want to do, and you always end it with end, and then it will. So now like the age is 6. If the age is, now I'm putting like the age 6. So what will happen? Nothing will happen. It will just like display this one and this one. Okay, so if I run this guy, I display hi and goodbye. Why it didn't display this message? Because this, like if age is greater than 3 and age is less than 5, then do whatever is here. Since age does not fall within this condition, then it will just skip this part and do this part. Like, let's try this for example, an age of 4. So if I put like age of 4, then you can start preschool education. Okay, so that is like how to like use an if statement. Now, I could also put else. So now here, like for example, let me show you like age of 9. So now, if age falls within the category, then display this. Else, you can do something else. Like else, you can display for example, I don't have information about that age, something like this. Okay, so now age is equal to 8. It will evaluate this. Is this true? No. Then it will do the else, which will be I don't have information about this age. If I put like age is equal to 0, for example, again, I don't have information about this age. Age equal to 5. Now, I don't have information about this age. Age equal to 4, then you can start preschool education. Something like this, okay? You can do like I showed you like an else statement. So here this is like an else statement. It will display hi. If the age is greater than 3 and less than 5, it will display, like all these commands. Whatever is here, that could be like 3 lines, that could be 1 million line, and then all other, and then else, so that is this condition, and then else all other cases, then you display, you can start like full-time education. So let me put like, so let me run this. If the age is 4, then it will like display this, it will come here, this criteria is true, then it will say like if your age is like, I'm taking here like the age, like passing this to here, is 4, you can start a full-time education. You cannot start here, you cannot start full-time education, but you can start preschool. Goodbye. Let's put like the age of 6, for example. If your age is 6, you can start full-time education. Something like this, then goodbye. You could also have else like different expression. So here like and then for different expression you use else if. So like expression 1, expression 2 till expression n. So here for example, you age is like, you know, if this will be executed for the age from 3 to 5, this will be executed from 5 to 12. This will be, if your age is only 12, this will be executed for 12, and this will be executed for any age larger than 12. So let's see what you can do if you are, for example, 8 years old. So if you are 8 years old, if your age is 8, you can start full-time education, but you cannot access your personal record. Let's say like 10. If your age is 10, you can start full-time education, but you cannot access your personal record, like 11, or like let's put 12. If your age is 12, you can start full-time education, you can access your personal record, but you cannot join a social networking site. I just put join here twice, okay? And so on. Like let's put like your age is 14, for example. So if your age is 14, you can start full-time education, access your personal record, and join a social networking site. Okay? Something like this. You could also do like expression 1, expression 2, expression. So here like you specify this expression, and then like you put else for all other cases. So that is like an example. Like here, this is from like the ages that we have seen before until like age 12. Now for all other cases, like if I inserted any age that is, for example, would be less than 3, then I don't have information for the age of whatever. So that basically will take care, because let's see, if I put here like age of 1, then clear. I'll put like, if I put in that case like age of 1, then it will display hi and goodbye. It's not going to display anything because the age of 1 does not fall in any of these categories. But if I want to just include for any other category, then you put like else here at the end. So for example, like if I put like the age of 1 again here, now it will say hi, and then I don't have information for the age of 1, because this is a statement about like this age is, this is an else if statement about this age is, about this age, about this age, and then this is for any other cases. Okay. You can nest an if condition, of course, because like an if condition inside an if condition. So here is like an example. So here, like under else, like all other cases, like I have like some additional condition. If age is larger than 0, display the age of this. You cannot like join preschool. Else, if any other cases like the age is like maybe 0 or -1 or not a number or infinity or whatever, then it will display that this is like an invalid age. Like let's put an age of -2, for example. So if I run this, then the age of -2 is at the age of -2 is an invalid age. Put in here. Is an invalid age, and goodbye. Okay. So basically that is, so here like this is an else, and then under else I'm putting two conditions. If it is like 0, or like let's say the age of 0.5, like you're half years old. Okay, so if you put like 0.5, then it will display at the age of 0.5 you cannot join preschool, goodbye, something like that. Okay. So this is the problem. You can use if condition to solve it. So let's just work on this problem. So here, like you have like a water tank for a city. The tank has like conical shape here. This is called like frostum conical because it's not like conical all the way to the end. So it has some area here and some other area here, and this is like a cylinder shape. And this tank has so let's read the problem. Giving the information of the water tank above, write a code to calculate the volume of water V that the city has, given H. So H, that would be like the height of the water here, as measured by sensor inside the tank. So like there is a sensor here inside the tank that's measuring the water level. And so basically, if the water level is here in this conical shape, then it will have, you will use like this equation, the volume for this conical shape here. If the water level is above this conical shape, then the volume of water would be the volume of water in the conical shape plus the volume of water within like the cylinder shape. Like, so that would be like, so your H, like your water height, that would be the height of the water here, and plus the height of the water in the cylinder part. If your height, for example, is just here, then it will like be the height in the conical shape here, the CF, and giving like whichever R here. And R is giving like R, CF, like this R here. This radius here is giving like as R2, which is, this is R2 plus your H here. So that's how you can calculate R. How to do like a problem like this? So basically you need, there are a lot of conditions actually. Like you might think that's only two conditions, when like my water level is in this shape only, or like my water level is in both shapes, like in this shape and that shape. Like if my water level is here, or just my water level is here only. No, there are more cases. Like what there is another case. What if the water level, like, so here this is 10, this is 20. So what if the water level is above 30? Like the water is overflowing from the tank. So that's another level. Fourth case is what if the sensor is not working? Like the sensor is giving you some bogus number, like giving you -1, or giving you infinity, or giving you not a number, or giving you anything else. So that's also, and you don't want your program to, so when you design a program, you want to account for all these cases, because you don't want your program to crash, with an error. So you need to account for all these cases. So that's how like if condition could be useful. So let's just write all our cases, and then we will see. So let's put any H here, like let's just put an arbitrary H value. Let's put like H is equal to 11. Okay, this is just an arbitrary H value, and then let's start our if condition. So like here, if, let's do this one first, like for the case that we have like water only in this conical part. So if H is like greater than or equal 0, okay, and H is less than 10, that would be like here, less than 10, then we have our HCF will be equal to the H, because whatever H is giving here, and h, like this hc, I mean hc will always be, you know, for any case would be always like h minus hcf, like, so that would be like whatever h I have here, because that's the equation, so hc will always be like h minus hcf. Okay, so that is like this first case. Okay, now else if, like, this is my second case, h is greater than or equal 10, okay, I don't know, so should, yeah, greater than or equal 10, that's okay, I'm not sure, and h is less than 30, because remember this is 10 and 10, so 30, like, because otherwise it would be overflowing, and h is less than or equal 30, then hcf, that would be like, it would be 10, because that means that's like, it's like greater than 10, so greater than or equal 10, so that would be like 10 here, and like the hc, the h here in this cylinder part, that would be the same, like h minus hcf, that would be the same as above. Okay, what is the third case? So the third case, if this thing is like overflowing. Okay, so if that thing is overflowing, now like that thing is overflowing, like means like h is like more than, like h was giving like something like 31, which really doesn't make sense, or like that could be an error also in the sensor, but like it's like giving than what the tank can take. So here, like, you can just display, because that doesn't make sense, you display a warning or an error, you display an error, h cannot be larger than 30, and then we can maybe reset, like h resetting h value to 30. So basically, like, if you got 31, then you can either like just leave an error message, or you can reset it to 30 if you want to do like the calculation. So in that case, like your hcf, that will be like equal to 10, okay, and your not cf, yeah, hc and hc, that will be equal to 20, okay. Right, I think I did this wrong here, that should be equal to 20, okay, and that should be equal to hcf is equal to this, like this, if h is larger than here, like, can make 30, can make it equal also, like larger than 30, then reset this value. Now else, so now if I got any other number, because maybe I got like a negative number, or I got like not a number, or I got like any other cases. So basically I have, here's a case from like 0 to 10, and then I have here the case from like 10 to 30, then I have the case here for larger than 30, and then if I got like any other case, why would I include any other case? Because again, I don't want my program to crash. Like what if the sensor is returning like not a number, or returning negative number, or returning anything that doesn't make sense? So here in that case, you display a message you display message, for example, like error, and then you say invalid h value, okay, invalid error, invalid h value, okay, and then end. Now, so now we have our h and hc for like all these cases that could happen. Now let's do the calculation, but when we do the calculation again, we can, and then we can say, like for example, hcf, we can say this is not in hand. We just set it to not in hand to give it like a flag like this, okay. Then now and if we have that case like an invalid number, we're not going to do any calculation. So now here we do like another if statement, like if hcf like is nan hcf, like if this is a nan, then maybe we will like display what do you want to display? We want to display like an error message, like we can display water volume not calculated. Okay, so that instead of your program like quitting or crashing with an error, it will just display like water volume is not calculated. Okay, water volume is not calculated. Else, then now finally we are writing our program. So now finally we are writing our program. So our program is that the volume in the conical shape that is equal to by hcf time RCF square. RCF is giving as R2 plus HCF. So let's just write our R first. So like R1 that is equal to 15 and R2 that's equal to 5. So R1 is equal to 15. R1 is equal to 5. Now here for this guy, we need to get like the RCF like this one, which is equal to R squared HCF. So that would be like RCF, that would be like R2 square, yes, just R2 plus HCF. Now we have R, and now like we have this is time, and we open bracket RCF square plus RCF time R2 plus R2 square, if I remember it correctly. Yes or no? So yes, RCF square, RCF time R2, and then like R2, well, I don't know if this is R2. Yes, this is R2, not R square. Yes, so that is correct. That's just R2 here. And then that would be like the volume in the conical shape. Do I divide by anything? Yes, and then you divide by 3. So I divide like this by 3. Then the volume in the cylinder, so that would be like by r square, which will be in that case like the r1. So r1 square times the height, which is the height in the conical shape. So that would be the height in the cylinder shape, I mean, not the conical shape. That would be the RH here, like this height here. So basically I put here and this height here, okay? And then like my volume would be like VCF plus VC, and then I can display like water volume is equal to plus number to string. I just put here like the V plus I put the V and then I put here meter cube, something like this. Okay, so now I have like H is equal to, let's make H is equal to 11, for example, to test our code if it's working or not. So if let me clear all output now. Let's test our code. So I'm putting H is equal to 11. So I'm displaying here like this guy is equal to this guy is equal to this. The water volume is like the summation of like these two guys, which is reasonable. Why? Because you get like more water in the conical shape than in the cylinder shape. Let's put H less than 10, like 9 for example. Then the volume in the conical shape should be equal to 0. The volume in the, because like if this is like 9 here, if the water level is here, then there's no water here and only will be some water here. Okay. So let's put a case, for example, H is equal to 0, then I should get like 0 for both of them. So if that is the case, then the water volume is like 0 for both of them. Let's put a case of like 31, where like the number. So the case of 31, then okay, I think I should put a section break here so that I don't get clear or output. So the case of 31, like if I run this, then I got an error message, error H cannot be larger than 30, resetting H value to 30. And here you might want to write 30 meter, resetting H value to 30 meter, and then use the volume in the conical shape, and this is the volume in the cylinder. And this makes sense because I mean, this is larger, like it has larger height and it has a shape that can take more water than this shape here. So basically you got like 1 order of magnitude more water in the cylinder shape than the conical shape. Okay, so that's a program that works because it doesn't, I mean, it accounts for all the cases. It does not have bugs in it. So let me just try to put like a bug, for example, like -2. So if I put like -2, like the sensor is just sending some -2. Then error, invalid H value. I mean, I don't necessarily need to display this. Invalid H value. Water volume is not calculated. Okay, the water volume is not calculated. Something like this. Okay. So here is this is like oops. I think there is this is leave this one. Okay. This is just some extra problem if you want to practice more if condition. Now let's do the switch condition, switch statement. So switch statement, this is like, I mean, I don't really use it much. Maybe I only use it, so it's like an if statement, but it's in a way that is very specific. Like, so you can think of a switch statement as like a programming construct, like if statement, but it's like very specific. So like you have a very specific case. So for example, like I put like CO2 is equivalent in particle per million. So if I have this case, for example, like switch case, so basically the user will input like a value here, and then it will just go for this specific case. If it found like that, if I put like 280, let me just put 280, then temperature rise will be like 0. If I just put 281, I'm not going to get anything because that case does not exist here. Like if statement, you say like if in this range, if in that, but here that is a very specific statement. Usually you use this if you want like user to input like a selection like 1, 2, 3 and then do something. So like if I put like the case of like 300, then let me clear all output. If I put like the case of 300, then temperature rise will be like 0.2. If I put like the case of 550, for example, then the temperature rise will be 2.5. If I put like this case, I don't get anything, okay? So here, like I put like a statement here, like so case, otherwise, so basically like otherwise, I don't have this case, I only like, so if I put like any value like 200, like and this number, so basically, and I run this, then I will go to otherwise. I don't have this case, I only have the cases of like these cases. One thing you can do also, like although that's very specific, you can just include more than one case. Like, so basically here, like if I put the case of 600, then the temperature rise will be something like this. I could put maybe the case of 700 also here. So if I put like the case of 700, so then you get like also 3. So that's as much flexibility as you can do with like these cases, versus here every statement you can just put anything. But here these are just like specific cases. Okay. You can also do cases with a string and with multiple conditions. So here, for example, like a greeting. So write a greeting here, like hi, hola, you know, aloha, whatever. Aloha, that's in Hawaii. So switch greeting. So greeting, like if I put hi, for example, then hi, this is greeting in English. So that like this case. If I put, for example, aloha, I don't have this greeting. So you can add it. So you can add this case. So the case of aloha, display, this is greeting in Hawaii, for example. Okay, so you can, and again, like you can also join like different cases. Like I could like add like bonjour, for example. Like if I put like bonjour, this is greeting in French, but I could put also salute. This is greeting in French. Okay, so you can do also cases not necessarily like with number. You can do them with string, and you can combine them. Okay. If I put anything like just salute without a T, then I don't have this greeting because this is otherwise here. Okay, so that's all for this like branches lesson. Again, these branches could be useful like in several cases, just as I showed you in this tank example, like to do calculation differently for specific cases and to make sure that you have enough cases so that your program will not crash. Okay. or enough like weird thing could happen so that your program will not crash. Okay, so that's all, and see you in the next lesson.